Welcome back to my channel as we continue the rebuild of the CS144 alternator. We have just finished cleaning the case with brake cleaner and wiped it down. So it was really dirty in there. The rest of the components, including the rotor, the slip ring, and the windings inside, I've shot with electric component spray. All right, I didn't want to take a chance with brake cleaner, so I did that as well with the bridge rectifier and the voltage regulator brush assembly as well. I shot it with electric component cleaner. So this is what I'm using, Electra Clean 3000. Check it out, not for automotive use. Well, I cleaned the components with it. I did not shoot it at an engine compartment, but it did the trick. Got my components cleaned. So the brushes showed some wear, but the rings definitely have wear on them. So that's not something that can just be sanded down. You can feel it with your fingers, real deep groove. So it's pretty bad. All right, so I'm gonna have to replace this whole piece right here. And the brushes, we checked them out. There's that wear. The bridge rectifier, we checked it out. We did some ohm readings and it's reading fine. So that's a good bridge rectifier. So we've got new brushes. They're right here, nice and complete, along with springs. But this slip ring, we're just gonna have to place an order online. All right, reminder, this is a junkyard piece. All right, so look at the rings. If I'm gonna bring another one home from the yard, I'm gonna have to open her up at the yard so I can know what I'm working with, because this is pretty bad. All right, if I can just clean up a slip ring, that'd be great, but this one has to be replaced. All right, and then brushes, they're just $5, $6, $7 parts at your local auto parts store. But a slip ring, if you got to replace that, that's a special order. All right, so I have to order that online. And the bridge rectifier, I'm also going to upgrade that to a 200 amp capable unit. So we're going to have to order that as well. All right, so it's more complicated than what I wanted, but at least I just didn't throw it onto my engine. So I'm glad I opened it up, and we're going to do those changes. All right, next up is removing the solder on the brush assembly to voltage regulator. All right, there are two areas where you have to remove solder. One is on this clip right here. If you move that brush right there, you'll see that metal clip. All right, so you have to remove the solder. So let's go ahead and do that. There it is. All right, so that's all it takes. The voltage regulator has a tab there, and the brushes right there, they have a little pocket where it slides onto the tab. So we're gonna go ahead and remove this and replace them with new ones. So what we're gonna do is just put them exactly how we see these old ones. So this one, the ring slips right on this round part. We're just gonna do a little reverse action. All right, so I removed one. You can see the indentation here on the clip itself. All right, that lines up to an indentation there on the plastic holder right there. Okay. Now we're gonna get the matching one. And of course the hole is gonna line up to the hole where it's gonna be held with the little pin. And there is a notch here for the wire to ride along. So that's how you're gonna install it. So I wrote just like this. Okay, so we're gonna do the same thing. Just slip it right on there, clip it on, and there it is, right? So let's put it just as we said. Just put it right in there. There it is. Okay. And of course, there's some springs that are gonna go in there. Okay, so for right now, we're gonna insert them, and then put them aside. So next one is this clip right here, which gets soldered. So this also has a little tab right there. See that? This is it right here. But it has a tab on the bottom where it kind of helps lock it on there. So when pulling it, we just gotta tug on that little area there. So let's go ahead and do that with some needle nose pliers. And there it is. All right, the reverse. We're gonna put the new ones on there. That's not good. Might have to get a new holder. You guys see that? That might be a problem. So that's not a good thing. All right, same thing. Let's put these right on here. It's gonna be soldered on there, so I don't see it as a big problem, but yikes. I got a little chip off the holder there. It's nice and steady there. All right, we're gonna put these aside. The springs go inside, and then we'll put a little pin in there. So I think I could have avoided that the proper way to do it. I mean, this is my first time doing it. I'm doing it with you guys. Here's an access port there. What not to do video. Access port there where you kind of push down on the tab as you pull it out. There should. So if you see, you could see the tab on there. So it should be able to be pressed down as you push it through. Even then, it's not as easy. But there it is. All right, my little mess up right there. Pushing it in. It's in place. It's not coming out easy. It's still, that tab is still keeping it up. But maybe I can put some epoxy there and close that up. So you need a little wall where that tab is gonna hold back against. All right. Found a small aluminum piece to hold the brushes in place. We're gonna put the springs in right now, actually, just for demonstration purposes. Because I am gonna do that little repair with epoxy. Unfortunately, that happened to me. Story of my life, it looks like. So we're gonna slip this brush out. Let's put the old springs on there just for now. It just takes some wiggling, but it's in there. Here's one. They will pop out, so you have to do it nice and careful. This goes on top, remember? Nice and easy. So you hold them, they wanna really pop out. It's on the other side of the plastic, but we're gonna pull it in a little. That way it makes it to the other side. There it is. All right, so that's pretty much what you have to do. All right. All right, so once again, what not to do. Do not yank it as I did earlier to remove the old one. All right, what you have to do, since I was testing these components out, my multimeter was nearby. I grabbed the end, and there's an access window here to lower the tab on there. So use that window, lower the tab and push it out. All right, I found the piece that goes here that acts as the wall for the tab. So when I pulled it, because I didn't lower the tab, it just forced itself out and broke that piece. So epoxy, or I will get a new holder. All right, next we are unsoldering the slip rings. To me, this is trash. I mean, look at this. You can feel it's not smooth at all. You can feel the ridges real deep. All right, so we're gonna see if we can unsolder these ends here and then try to take it apart. Seemed to melt what was the lock ring and even the base material here. So we're gonna try to just pry on this. We're trying a new method and see what I can uncover. All right, so it seems to be prying off a little here. This whole thing is what gets replaced on this CS144. The slip rings along with the base here that goes the distance. And that broke a chunk off. All right, so it seems so far that that wire that's sticking up, it's going into the internal part of that base for this guy here. I'm gonna get some better tools and wedge that thing up. All right, so I was just gonna show you guys the finished product of this being removed, but as you can see, I went at it and removed the sides here. They're not just removable, I broke them off by prying screwdrivers, and they broke off. We're gonna remove this piece and we're gonna take a closer look. And it's pulling up, so I keep pulling out different tools. All right, here's a piece. I'm just gonna kind of hammer to try to wedge it up further. Not really hammer. I'm still using my pliers here. Little taps. Little love taps. Also, you guys can see, we see where it is secured on these ridges here, on these splines. All right, so it has to be helped up. It needs to be pried up. Wedge it up. Just tapping it down seems to bring it up. Okay. All right, there it is. There it is. All right, so this piece, it's the color of a black plastic. So maybe it wasn't some sort of cast iron. All right, maybe it was plastic. The inside, the breakage looks similar to that of the cast iron brake. So my original suspicion of it being part of this slip ring is correct. Okay, so it's a process, but we were able to take it off. I left some nubs here so we can do some soldering action. I wish this was longer. It's a smaller nub than this one, but depending on how it looks when we receive it, there it is. And then to install it, I'm sure we'll use a socket to smack it down. All right, and here's the result of the cleanup. So if you look carefully, there is wiring there. So I did not use a drill to go through there, although I did use the attachment by hand. Okay, so cleaned up the wiring there. Before I did that, I did use the hot iron right around the base here, and there was melted black stuff that smelled like burnt melting plastic. So that's what it was, including what looked like a lock ring was plastic. It just never made it out live. Just melted. So this was all painted orange underneath here. So I don't know whether to just touch it up with paint. If it serves a specific purpose. I mean, everything's sprayed on like that. It's a specific paint, but here are the soldering points. I don't think I need to let's see if I can do a close-up of that soldering there. There it is. So it looks like several strands of wire, but really it's a little bracket crimp thing that's holding one strand of copper together. Same on the other side. And the heat on my soldering gun is not melting it any further. All right, so we're gonna use this point here for our new slip rings and base. And I think the base should have little holes on each side. So if these fit through the hole, you can just solder that area there. And this should be tight enough to hold it tight. This is for the electrical part to be having a good connection here. Next up, we're trying to figure out how to take this rotor out. You can't really feel a big wiggle, but it's if you can feel it if you go just back and forth. So now that I'm doing everything, might as well replace the actual bearing. I don't know, maybe you can see it move. See that slight movement? I don't have a hydraulic press. I'm gonna try to manually press it with a drill press here. So I'm gonna put something in there that will fit nicely on that stud, on that nub. I'm gonna insert this backwards like you do with a extra drill bit, and then we'll press down with that, and I'll put some spacers on the side to support the actual case. And we're gonna see if I can do it just with manual power. All right, this is what we have so far. Here's your replacement. The other end of the rotor is right there. So it can get pushed down through the hole. There's enough space for it to go down, the actual round part, the orange part, and it's supported on part of the case here. So there we are. So we're gonna push this down manually. You're gonna see the knob just going to the hex part of the nose there. So let's go ahead and try to just push it down. That's it. Easy, right? Wow. Easier than I thought. That's pretty cool. So I didn't have to hammer it. It's pretty down low now. Orange hasn't touched the ground. We're just gonna finish the job. That's it. All right, we're gonna check it out. All right, so I took the case off of this stud part of the rotor. There's like a spacer that came down, and there's a spacer on top. And we're gonna check out the other side. So this is the clip that holds the bearing for this particular case, clipped on 3 sides. So we'll go ahead and order this bearing and change it out. All right, guys, here is the case we just removed. So we're gonna remove these clips right here. We're just gonna try to pry them off and take that clip off. Let's start with this. So we're gonna go ahead and see if we can grab a little area to pry on. Maybe the crevice in here. All right, that seems to work. We're gonna leave that just like that. We'll go side by side, the clip back on. So if we can push down while we're doing that, maybe it won't clip back on. All right, clips off. And it's all in one piece. We didn't break it. So it should still be good to go. What's left is this bearing. And we have a part number on here. 6303RSH. There you go. 6303RSH. So we're gonna go ahead and remove this, and we'll probably use the same manual method since I don't have a hydraulic press. All right, let's look at our setup here for this bearing here. On this side, it only exposes the middle part. When you install it, obviously you have to be careful for the middle part, or you get some messed up bearings or wiggle action, as I see now. Not right now, but when the whole thing was on there, there was a little bit of wiggling. So in the back, we have to support this metal area here. We don't want to damage the structure here. So I found this piece that just sits nicely right there, and it fits nicely on my my drill press. So I'm just gonna remove this guy that was on there. We're gonna insert it so it can be supported right on there. If you can see carefully, it'll be right on there. And we're gonna use this to press it down. All right, so manually that didn't work. We're gonna use the same tools to support the case in the back here around the bearing. All right, and we're gonna use the same socket. 17, I believe, is this one. All right, that we're gonna use to hammer that in its place. So let's go ahead and remove this bit, and we will be hammering this one down. You feel it going down already. I'll show you guys what it's like so far. Nice and easy. Now what I'm hammering right now is that inner race. We don't want to do that when we install it, or else we'll mess it up. We're gonna have to find a socket that fits right around the outer part, the outer race. All right, that's up. Looks nice and clean in there. All right, looks like there's some white stuff in here. That's actually from this guy, not the bearing. All right, so there you go. Time to get a new bearing, put it in place. I don't see any traces of red Loctite on this particular thing. All right, there you go. Removal of bearings from the front of the case of a CS144 alternator case. All right, so here we have side-by-side comparison of the old slip ring that was on the rotor here. In order to take it off, I broke the base, which is some sort of hard material, plastic maybe. But it has a wire exposed where eventually it gets soldered over to these guys. The replacement is the same height, same shape inside. See that? But I believe it was wider. The base was wider. And I think this plastic protrudes further out. So I might have to do something to this. So check it out. This is the original one. So it'll reach and be soldered. Whereas this one, okay. So if you see that, it's a little longer. So this isn't orange paint. It's not just paint, it's varnish. It's specifically made to insulate electrical parts like these alternators. So we'll get some paint on there. I'll tape the wires so I don't do that, but I'll put that orange varnish on there and slip the ring over. And that's what I'm gonna use. All right, anti-seize A technology, red insulating varnish. The slip rings here should continue to be insulated. And a lot of the rotors you see out there, the wire is already insulated coming out here where you can safely solder on top of connection here. My guess is where this wire is coming through that it's insulated. I mean, I can't imagine just it touching the metal here. So I think it's filled in with some sort of rubberized filling or something. I try to clean it as much as possible. And I think I see a round area there where it's cushioned in. At least that's my theory. All right, we're here testing out the slip ring, the rotor, and showing you guys the slip rings and how to test them. All right, there's continuity from this wiring to these wires sticking out. These are the wires that usually come out the sides when you see other rotors. But this one is coming out through the metal base, which seems kind of weird. You would think it would touch the metal, but my theory was that it's insulated If there's a hole drilled through there, that hole is filled with insulation, or the wires in the middle of that insulation. So it's protected inside. Now here's a near slip ring where I kind of broke off the edges because it's not quite made for this particular application here. Now there should be continuity between this shaft and basically the ground. There is some exposed metal here. There we go. See, it's sanded down, and this is why I want to spray it too with the varnish I spoke about. So the shaft and ground should have continuity. So if you see the multimeter, the numbers are moving. All right. Now there shouldn't be continuity between the ground here and this wire. This wire is what gets soldered over to the slip rings. So we're gonna touch this bare metal to the shaft again, and it's moving. The numbers are moving. That means continuity, and we're gonna touch it to the extra wire here. And there is no continuity. That's what we want. Okay, we touch the edge here, no continuity. So that's the insulated part. There's like a little perimeter around it. And we go off that edge, and the numbers start moving. So there is a little circle of space where there's no continuity. So when we solder this, we have to be careful that the wiring does not touch the base. Okay, the wiring coming out of the slip rings. When we place it on there, there's just a specific amount of space. And we're gonna test the other side too. Let's test the shaft again with this bare metal. And the numbers are moving, continuity. And we're gonna touch the other wire on the other side. And there's no continuity. All right, we touch around the base, where I suspect it's insulated, and it's not moving. There's no continuity there. So we're pretty good. We move off the edge a little, off that circle, and the numbers start moving. There's continuity. There you go. This one seems to test A-OK on continuity without the slip rings. I'm just trying to poke at the wires here. The wires themselves seem to be insulated, so there's no continuity there. All right, we want them protected, insulated. No numbers are moving. That's good. I'm not gonna try to rub it off. So when I spray this, I may spray inside the wiring area to continue some protection there. But here's some like looks like exposed wire. No, it's probably all insulated. All right. That's the testing, and we'll go ahead and test it once the slip rings are installed. All right, up next for testing is the stator. We're going to continue with our multimeter and the ohms setting for continuity. So these have different windings. There are 3 that are interconnected. So we're going to go test them with each other, and there should be readings. And then we're going to touch the next one. There should be readings on that too. And on the next one. And then we're just going to switch them back. All right, so there seems to be reading on each one. All right, so now the stator has this metal base. All right, that's like the ground. So when touching that and each winding, there shouldn't be any continuity. So far there's no readings, so that's a good sign. There's no leaks. So that's it for the testing on all our components. Now we're just getting new parts. So hit a like and subscribe to follow us on part 3 as we complete this rebuild.